In this lesson, you'll learn how to find the area of triangles involving sine. Let's start with this question. Give an equation that can be used to find the height of this triangle. We'll let this left-hand side be a length of 12 centimeters, and we'll give the base a length of 22 centimeters. And this included angle here is going to be 63 degrees. Now we need to also label the height, so we'll drop a perpendicular from this highest point and make a 90-degree angle here and label this H. To answer this question, we're just going to focus on this right triangle right here. So let me sketch that off to the side. And we'll have 12 centimeters for the hypotenuse and a 63-degree angle here. And we're looking for this height. We don't know what the base is, but we don't need that measure. Sine will work well for finding H in this case. The sine of any angle, so we'll write sine of theta, is going to equal the length of the opposite side over the length of the hypotenuse. So filling in what we have, we'll have the sine of 63 degrees is equal to the length of the opposite side, which is going to be h, divided by the length of the hypotenuse, and 12 centimeters is the length of our hypotenuse. This gives us an equation we can use to find h. Now for part B, it says actually find h, so let's go ahead and manipulate this equation to give us h. By multiplying both sides by 12, we'll get 12 times the sine of 63 degrees equals h. And then we can use our calculators to calculate 12 times the sine of 63 degrees. Just be careful that your calculator is in degrees and not radians. Rounding our answer to the nearest tenth of a centimeter gives 10.7 centimeters. Always look back and make sure that your answer makes sense. In this case, we know that it has to be shorter than 12 centimeters because 12 centimeters is the hypotenuse, so that's the longest side. It does look like a good answer. Now let's take a look at another question. Find the area of triangle ABC. Let's first take a look at the triangle before we try to solve anything. We've got angles A, B, and C marked, and we have that angle B equals 91 degrees. We don't have the sides marked, so let's take a minute and do that. Across from the angle A has to be side A. And across from angle B, of course, is going to be side B. And across from angle C will be side C. I think this makes it a little easier when it's time to use a formula. Now we have three formulas to consider, and we have to decide which one we're going to use. We have all three side measures, so that's not going to limit us, but we only have one angle measure. So let's choose this formula since we have the measure of side A, the measure of side C, and we have the measure of angle B. We can just plug in the values that we have. We have the area equals 1/2 times the length of side A, which is 13 miles, times the length of side C, which is 7 miles, times the sine of angle B, which is 91 degrees. Again, be careful that your calculator is in degrees and not radians, and just evaluate this in your calculator. If we round it to the nearest tenth, it's going to be 45.5, and our units are going to be miles squared. Now, let's look at another question. The purpose of this question is just to emphasize what information you need in order to be able to use these formulas. So the question here is going to be which of these three triangles gives enough information or gives the correct information for you to be able to use these formulas for the area of a triangle. Notice that each of these formulas requires that you have two sides and the angle that's between those two sides. We call that the included angle. For the first formula, you would need side AB and then angle C. For the second, you'd need side AC and angle B. And then for the third, you'd need side BC and angle A. Let's take a look at the first triangle and see if we have enough information to apply one of these formulas. The first triangle gives us two angle measures and an included side measure, and that's not going to be enough to use any of these formulas. We need two sides and the included angle, not two angles and the included side. Let's take a look at the second triangle. We have two side measures and a non-included angle measure. Again, two sides are great, but the non-included angle isn't going to work with any of these formulas. And just to make sure that's clear, we have side A, and we have across from B would be side B. And then we have angle A. So for side A and B, that would be this formula, and that would give us area equals 1/2 times side A is 27, side B is 38, and then we would need the sine of angle C, and we don't have that. So we would be left with sine c. So that would give us a variable here that we're trying to solve for and a missing variable over here. So that would be impossible. Now let's look at the third triangle. The third triangle gives us two side measures and an included angle measure. And that's what we're looking for. For this one, we can solve and find the area of this triangle. Let's go ahead and follow through and find the area of this triangle. Across from angle C, we have the measure of side C, and across from angle B, we have the measure of side B. We also have the measure of angle A. So that gives us enough information to use the formula A equals, we have B and C, so we're going to use this last one here. A equals 1/2 times the length of side B, which is 38, times the length of side C, which is 30, times the sine of angle A, which is a 45-degree angle. And when we evaluate this in our calculators, we're going to get 403 1/10 square feet for the area of the triangle. Now let's take a look at one more problem where we're given the area of the triangle this time and asked to find a side length. Here we're given triangle ABC and we're given the information as follows. The area of the triangle is 96 3/10 meters squared. The measure of angle B is 58 degrees and the length of side AB is 16 meters. Let's put that on our triangle. So the measure of angle B is 58 degrees. Let's put the 58 here. And the area of the total triangle is 96.3 square meters. You could leave that off or put it in. We do want to include the length of AB. The length of AB is 16 meters. And for the sake of using our formula, we might want to note that side AB is the same thing as side C. It's across from angle C, so this actually equals lowercase c. Let's go ahead and label side A here, because that's what we're looking for. The length of CB runs here, but that's also called A because it's across from angle A. Now let's get our formula. That's going to be the area of this triangle is going to equal 1/2 times the two side measures that have the included angle. So that's going to be side A and side C times the sine of angle B. And take a second and make sure you see where these came from. We have side C, we're looking for side A, and here's our included angle, which is angle B. So that's the formula we're using. Let's fill in what we have. We have that the total area of this triangle is 96.3. The 1/2 is always in the formula. The measure of side A is what we're looking for, and the measure of side C is 16 meters. And the measure of angle B is 58, so we'll take the sine of 58 degrees and put it here. Let's first get rid of the fraction. We don't have to do that, but that might be nice. If we double both sides or multiply both sides by 2, that's going to give us 192 6/10 on this side. And over here, that'll give us A times 16 times the sine of 58 degrees. You could go ahead and simplify the right-hand side, but that's going to give you an awkward decimal to work with. So why not go ahead and divide both sides by 16 times the sine of 58 before simplifying. That'll give us 192 6/10 divided by 16 times the sine of 58 degrees. And this side will be A times 16 times sine of 58 degrees divided by 16 sine 58 degrees. And both of these, the 16 and the 16 goes to 1, and the sine of 58 degrees and the sine of 58 degrees goes to 1. So our equation is going to look like this. A equals 192 6/10 divided by 16 times the sine of 58 degrees. For the last step, you'll want to put this in your calculator and get an approximation. The length of side A is going to be about 14.2 meters. Hopefully you're trying this along with me, because the most common mistake in this whole problem is simply to do the division step wrong at the end. A lot of students will do 192.6 divided by 16 times sine of 58, not using any parentheses, and what that does is take the sine of 58 degrees and put it in the numerator. So be careful how you do this. Check and make sure that your answer agrees with my answer, and you're going to get it right every time. Now you know a bit more about finding the area of triangles using sine. See you next time.